Welcome to Peaks to Power, a podcast brought to you by the National Laboratory of the Rockies. I'm Taylor Mankel.
And I'm Karen Jerriman. It's Wednesday, August 12th. Hey, Taylor, how's it going, my friend?
Hey, Karen. Oh, not too shabby. It's a busy time of year around here. How about yourself? How you doing?
Yeah, busy, loving summer, really loving summer. Don't want it to end ever. Taylor, the laboratory is on the heels of some really exciting announcements that we'll be getting into today.
Yeah, that's right, Karen. Last month, NLR received 12 project awards in the Department of Energy's Genesis mission, and the lab announced a collaboration with Argonne and Oak Ridge National Laboratories to create a new national center for membrane technologies.
That's right, and we'll share about a recently published report that evaluates the potential of 5 emerging aviation fuels.
Got some really impactful headlines there. Let's get into it.
Okay, you might have heard some chatter recently about the Genesis mission, the Department of Energy's national initiative to build the world's most powerful integrated science discovery platform through advanced AI, high-performance computing, and expertise from leading researchers across the country.
On July 22nd, the Department of Energy announced the first projects selected in the Genesis mission Phase 1 requests for applications. After a historic number of applications, 278 projects were selected, and NLR received 12 project awards.
NLR will lead 4 of those projects, ranging from semiconductor research to smarter weather modeling, and our researchers will be key collaborators on the other 8 awards.
Phase 1 projects are intended to design and demonstrate research workflows that integrate AI with scientific investigation and then evaluate whether those approaches can accelerate discovery, improve predictive capabilities, enhance experimentation, or generate new scientific insights.
That's right. NLR's 4 projects cover a lot of ground, from predicting how turbulent flow causes dangerous vibration in infrastructure before it fails, to analyzing the science of electricity in next-generation semiconductors, developing weather models that better predict rainfall and water availability for the grid, and deploying AI agents to accelerate the development of fuel cell catalysts.
NLR's director Judd Verdon said, quote, "These capabilities and partnerships are critical to our ability to reliably advance and scale energy sources and infrastructure and reduce reliance on imported critical materials," unquote.
12 projects that are extending the laboratory's work on promising pathways toward transformative scientific capabilities. Now that is important stuff. Our next story is an announcement that spans from Colorado to Illinois, Tennessee, and everywhere in between. And, well, around as well. This is something the whole nation could benefit from.
In collaboration with Argonne and Oak Ridge National Laboratories, NLR is leading the creation of a national, user-focused membrane center to help national laboratories, industry, and academia develop and pilot new membrane technologies.
We're saying membrane a lot, but what does that actually mean? Membranes are thin layers of selective, semi-permeable materials that allow the separation of certain molecules from others. They're widely used for liquid and gas separation and electrochemical processes, and you can find them in a range of industries, including water purification, food and beverage production, chemical manufacturing, critical mineral recovery, and petroleum refining.
A $12 million award by the Department of Energy's Industrial Technologies Office will establish membrane engineering for manufacturing, benchmarking, research analysis, and next-gen evaluation. That acronym is, as you may have guessed, membrane, as a national center, which will enhance the existing capabilities at the 3 national laboratories.
That's right. A key goal of the Membrane Center will be to bridge what's called the Valley of Death. That's step between basic laboratory research and industrial scale where ideas struggle to take off.
To address this challenge, researchers from the Membrane Center will establish the United States' first membrane market development facility. That will host the equipment needed to manufacture new membrane materials at large sizes, package them in industrially relevant modules, and then test them under the same conditions they'll encounter in industrial applications.
The center will rely on input from and close collaboration with industry partners to ensure its work is addressing key industry needs, supporting membrane development and device prototyping and testing.
By accelerating and optimizing the scale-up of new membrane materials, researchers can reduce the energy costs and water demand of American industries, helping to make those industries more cost-competitive, which ultimately saves money for consumers.
Ah, yes, that's the good old technology transfer pipeline at work.
Our final story today features new research that could help with the sticker shock when purchasing plane tickets by looking at the fuels that fly passengers from point A to B.
Tight jet fuel supplies and a growing demand for jet fuel are intensifying interest in an aviation fuel mix that extends beyond Jet A and A1, the most widely used aviation fuels in the world.
Boosting production of emerging aviation fuels could help stabilize the domestic market, helping insulate the aviation industry and travelers from rising costs caused by supply chain volatility.
NLR researchers are actively working to clear those new fuels for takeoff, with a newly released flagship report funded by NASA that explores the production potential of 5 fuels: SAF, liquid hydrogen, liquefied natural gas, liquefied ethane, and Jet X.
Of all the potential fuels surveyed in the report, SAF is already a commercial available drop-in aviation fuel that can replace up to 50% of the Jet A required by traditional aircraft.
But if SAF is going to meet future jet fuel demands, it needs buy-in from many stakeholders and further efforts to reduce costs. Producing SAF at the same price as Jet A or A1 today would prove very challenging. Lower capital and operating costs for new plants and refinery conversions, as well as enough feedstocks, would all be needed to produce fuel at scale.
As for fuels of the liquefied variety, liquid hydrogen, liquefied natural gas, and liquefied ethane, these are not quite drop-in solutions for aircraft at this time. Known as cryogenic fuels, these fuels are stored in insulated tanks, often at low temperatures, to maintain their liquid state.
That means airports would need to install new fueling infrastructure, and manufacturers would need to bring new planes to market that could be fueled by hydrogen, liquefied natural gas, or ethane. International standards would need to be developed for safely handling and dispensing cryogenic fuels.
Even still, cryogenic fuels are worth exploring because they could help diversify our fuel supply using domestic energy sources, says Christy Moriarty, a senior vehicle and infrastructure analysis researcher at NLR who led the study. Using domestic energy sources has important consequences for our energy security and the prices airlines and consumers ultimately have to pay.
The last fuel in the analysis is Jet X, which is in such early stage research that it would need extensive long-term studies to prove its compatibility with airport and aircraft equipment. Much too soon to tell with this one, Taylor.
Right, but NLR researchers are on it. The laboratory's fuels and combustion researchers are using NLR's virtual jet engine to create ultra-detailed simulations of how new jet fuel chemistries perform, which can help speed up production and certification of new synthetic fuels.
Research teams are also helping to prepare the aviation sector for the rise of advanced air mobility, which leverages aircraft that require less jet fuel or none at all. The lab's work is informing designs for very futuristic-feeling things like electric vertical takeoff and landing aircraft. That's planes that take off vertically, like helicopters. Also propulsion systems for electric passenger aircraft, and ultra-efficient power electronics to help aircraft travel farther on less fuel.
And with continued research, scientists can help lower costs and scale up production to bring emerging fuels to the marketplace, building momentum towards the future of flight.
12 Genesis projects, 1 new membrane center, and a look toward the future of aviation.
Future technologies are moving fast. Listeners, thanks for coming to Peace to Power to learn all about them.
And if you like this episode, give us a review on your favorite podcast player, or you can send us an email at podcast@nlr.gov.
Stay curious, everyone, and we'll see you in 2 weeks with more news from the National Laboratory of the Rockies. This episode was adapted from National Laboratory of the Rockies news articles from July 2026, written by Harrison Dreves, Wayne Hicks, and Anna Squires. Our theme music is written and performed by Ted Vaca, and episode music by Chuck Kernick, Jim Riley, and Mark Sanseverino of Drift BC. This podcast is produced by the National Laboratory of the Rockies Communications Office.